Welcome to the first video of Module 3. This video is covering 5.1 and it's basically reading graphs. At this point in time in your life, you should be able to read a graph pretty easily because we covered that all the way back in Module 1. But there's some things that we're going to be doing in this particular section that is taking that basic understanding of the graph and taking it just a little step farther. One of the biggest things that we're going to be talking about is percent change, reading a graph and calculating percent change. And what percent change is it is the increase or decrease of a quantity by a percentage. Alright, long story short, you go to the checkout and they give you a 7% tax. That is a percent change. It is changing from what it was before taxes to what it is after taxes. That's a percent change. Or you go to Walmart and you're going to buy something, but it's on sale for 20% off or something like that. That is a percent change. It's going from what the normal price is to what the sale price is. Okay, so that's kind of a way to do it. And the way we calculate percent change is we take this is kind of a basic equation. We're going to say the new minus the old over old times 100. What am I talking about here? It's the new number that you're going to be working with minus the number that you first began. Alright, so let's use this, and it's easier to understand when you see this actually in a problem. Alright, so let me erase my board. Yep, I don't have a sock anymore. Anyway, moving on. The very first problem says I was 315 pounds, but I am now 300 pounds. Alright, so kind of going back to that formula, it is the new minus the old. Well, it says I was 315. Well, that makes sense to be my old. So wherever old is, I'm going to put 315. My new weight is 300 pounds. I was 315, so that's where my old goes, and my new weight is 300. I'm going to multiply this by 100 because that's what my equation tells you to do. Well, when I work this out, 300 minus 15 is going to give me negative 15 over 315 times 100. When you plug this in your calculator, you're going to get something that looks like this. Negative 4.76, and it gives you a bunch more numbers. Well, what is this telling you? That, let's just round to the nearest tenth, that it's negative 4.8%. So what does this mean? Well, look, my weight was 315, but I went to 300, so I lost weight. That's what the negative's telling me. I lost 4.8% of my original weight. I was 315 pounds, but I lost 4.8%, and I'm now at about 300 pounds. That's what the negative is telling me. It is a loss. Okay. Now, this is probably more accurate. Is the next one. I was 300 pounds, but I'm now 315. I was 300, so that's my old. Alright, I was 300, but I'm now 315. This is my new, just don't forget, my old, new minus old, divide by old. Alright, well, what's that give me? Well, that gives me 15 over 300. Oh, this was supposed to be multiplied by 100. Equals 15 over 100 times 100. Work all this out, and you get approximately 5%. I was 300 pounds, but look, this is a positive number, so I gained 5%. Therefore, my new weight is 315. That's what it means about percent change. I went from my old to my new, and I'm finding out, was it a percent increase or a percent decrease? Alright, so it makes sense. If you lose something, you lose weight, it's going to be a percent decrease. And your answer is going to be a negative. If you gain something, it's a percent increase, and your answer is going to be a positive percentage. So another example of a percent decrease might be a sales. Okay, something is 20% off. Well, that's negative 20%. Or a positive increase would be tax. Your tax is 8%, so it's a positive 8%. All right, so let's move it on. This kind of goes back to kind of touching on this. It's calculating percent increase. In your notes, I say when a quantity is added by a percentage of that same quantity. Let's just go to the. It says Josh is making $10.50 an hour. His boss gives him a 5% raise. What is his new pay rate? All right, so basically you need to solve this problem. You need to find out first what is 5% of $10.50. We'll go all the way back to Module 1. This is the first step you're trying to find. What is 5% of $10.50? That's the first thing you're trying to figure out. Well, do you remember how we do this? We don't know what that is, so we can say that's X is 5, we change it to a decimal, times $10.50. We find out, when we mark this all the way out, that we get 0.525. All right, so this is how much Josh is actually going to get on top of his normal pay. He's going to be given a raise of $0.525. All right, so what you're going to do now is you're going to add this back to $10.50. And when we do, now we'll go ahead and round it. We're going to get $11.03. So Josh got a 5% increase, and in doing so, he is now getting paid $11.03. Now, there's another way that we can do this. If you know that you are trying to calculate 5% of $10.50, you can just say simply 0.05 times $10.50, all right, and I would put these in parentheses, then add $10.50. This is the quick and easy way of finding out percent increase by putting it in a calculator. You know the percentage, you know the original number, and then you add the original number. And when you do, you get the exact same thing. So Josh is getting $11.03. All right, so what I'm going to do is I'm actually going to do the rest of my problems like this, because I don't want to have to write what is percentage, blah, blah, blah. Okay? So, it says you're shopping at Walmart, excuse me, and your subtotal is $142.88. The sales tax is 8%. What is your total cost? So, you know that how this works. You have to find 8% of $142.88. That's the first thing you need to find. And once you find this, you're going to add it back to your original subtotal. This is going to calculate your tax, your physical tax, and then when you put it together, it's going to give you your final total. So when we do this, you get 11.4304 plus 142.88. Add this together, you get 154.3104. Now the problem tells you to round to the nearest penny. My penny is right here, so that 0 tells that 1 to stay the same. So my final answer is $154.31. So that is how much your bill at Walmart cost after an 8% sales tax. It is an 8% increase. All right, next one. You went out for lunch and your total bill is $26.59. You want to leave a 15% tip. How much was your lunch including tip? So same thing. I need to find out how much I'm going to give that tip, that waitress a tip, okay? So let's just calculate the tip. How do we do that? Well, we need to go 15% by changing it to a decimal, just like we've been doing back in Module 1, times my cost, which is $26.59. And then whatever this physically is, we're going to add it to the original bill. and then we're going to solve for it. I'm going to be lazy. I'm going to plug all this in my calculator. I'm going to put 0.5. Now make sure you do your parentheses. So 0.15, 26.59. I'll do it right here. It gives you 3.9885. And we're going to add the 2659 all together. You're going to get 30.57. Oops, that's a 30. 30.5785. This is what you get. However, you're not going to pay that. You need to round to the nearest penny. Your penny is here, so that 8 tells that 7 to go up. So your final cost is $30.58. Again, all right, my original bill was $26.59. I added a 15% tip. Altogether, $30.58. Okay. Now, percent decrease is very similar to percent increase, but think about it. If I'm adding for increasing, what am I really going to do for decreasing? Well, I'm going to subtract. All right? So, same principle applies in that we've got to find the percentage and the actual physical value. But then we're going to have to do some manipulating. So, let's just take a look at it. A rug that is $49.99 is on sale for 20%. What is the cost of the rug? Well, I know that the cost is $49.99, but I need to subtract how much that 20% is. Well, I need to find out 20% of this same number. So all I'm going to do is say this: minus 20%, 0.2. Let's put 0.2. 0.2 times my $49.99. When I do, I get $49.99 minus $9.998. This is the exact number. So this is the cost of the rug. This is the cost of the discount. So now I know what the discount is. I'm going to subtract these two numbers. When I do, my final answer gets to be 39.992. But this is not how we write money, so we're going to round to the nearest penny again. And it's going to be $39.99. So, a rug that is $49.99, when a 20% discount is taken off, will get us $39.99. All right, the next one. It says I am 305 pounds, and that's actually pretty accurate. The doctor basically says I'm fat. All right, and he wants me to lose 25% of my weight. How much does he want me to actually weigh? All right, so same principle. I know that my starting point is I'm currently 305 pounds, but I need to lose 25% of that. So how do I do that? It's 305 minus, well, I need to find out what 25% of 305 pounds is. So that's what I've done, 25% of 305. When I do, I'm going to get 305 minus, oops, looking at the wrong one, 76.25. Alright, so this is how much the doctor actually wants me to lose. This is 25% of my weight. He wants me to lose 76.25 pounds. So when I subtract this all the way out, I get 228.75. Now, round to the nearest pound is what the problem says. So my pound is this 8. This 7 tells that 8 to go up. So I'm actually wanting to get to 229. That's what the doctor wants me to get to. But I'm going to go ahead and tell you, that's going to be a long, hard fight. It ain't happening anytime soon. Alright, so this is how much I currently weigh. I took the percentage off, and I got that. Alright, this last one's a little multi-step, but if you think this one through, it's not so bad. I'm actually kind of would like you to pause it first. So, I don't know, I haven't been doing pauses in it, but pause right now and try this one on your own. Think it through, and I'll come back. Hopefully you paused it. If you did, good for you. If you tried it, awesome sauce. If you didn't, shame on you and slap your hand. Okay, now moving on with our life. It says the government takes 31% of my gross income. That's not too far from the truth. They usually take about a third of your paycheck, maybe a little bit less, so that's pretty accurate, around 31%. So the government takes about 31% of my gross income. If I work 40 hours a week at $15.50 an hour, how much do I get paid a week after taxes? Okay. So first off, we need to calculate one thing. How much am I actually getting paid a week? Well, first off, we know that I'm getting 40 hours a week, and I also know that I'm getting paid $15.50. So when I do that, 40 hours at $15.50, multiply the two, I should be getting around $620 a week. This is my gross income. Gross income is what you make before taxes have been taken out. How do you know this is the gross income? Well, the government thinks it's gross for you to have money. That's why they take taxes out. That's how you can tell this is the gross. They haven't taken taxes out, so the government thinks it's gross. It's disgusting that you have money, so they have to take taxes out. All right? Hopefully you'll understand that. All right, now, because the government thinks this is gross for you to have money, I am going to have to take 31% out. So I'm going to start with 620, but I'm going to subtract 31%, so that's 0.31 of my gross income. So 0.31 times 620. When I do, I get 620 minus 192.2. Work this all the way out, and I get, well, just make sure you understand this 192.2 is what they're taking out in taxes. So when I physically subtract this out, I only get $427.80. So even though I made 620, government thought it was gross, so they took out taxes and they left me with what's called my net. This is actually what I made. All right, now that right there gives the basis of all the things that I really wanted to cover about in this particular module. So we've talked about percent changes, percent increase, percent decrease, and how they all work. What I want to do now is I'm going to cut to the computer and I'm going to show you a couple of problems that I want you to be cautious on, and then we'll end the video. All right, see you in a minute. So in this second half of the video, I'm just going to go over a couple of problems with you. Most of them I'll try to speed through, but there are a few things I really want to take a little bit more time with. The other thing is I've given you 2 blank sheets of paper in your notes. Those sheets are for you to take notes from this half of the video and anything that you feel like you really would like to write down. I'm not going to be grading your notes on the second half because everything is coming directly from the computer and it's just how you want to take your notes, okay? The other part is that I'm going to do your quiz on this video on the first half of the video where we did the problems on the board. All right, so with that said, let's just go ahead and get into it. All right, I'm not going to spend a lot of time on this except for look at this problem. It says, during which year did the largest increase occur? Well, the first thing that most people answer is they look at the numbers and they say, hey, the biggest year is in 1996. So what happens when I do that? 1996. It tells me I'm wrong because look at what it's telling you to do. It's asking for the largest gain when compared to the previous year. So look at it. Did this gain? Yes. Did this gain? Oh boy, from 94 to 95 there was a huge gain. Then from 95 to 96 there was a small gain. So which was the biggest gain? Well, it was in 1995. Look, I mean, you can see that physically. All right, determine the total sales for 1994. Okay, read the graph. 1994 has 2215, 2,215. Done.
How many more sales were in 95 than in 94? Well, you know how many are in 95, 3,382. You know how many are in 94, which is 2,215. You want to know the physical difference between the two, so you're going to subtract 3,382 minus 2,215, and you get that there is $1,167 more. That's it. Now, this is the one that I really wanted to take a little bit more time in. By what percent did sales increase from 94 to 95? This is a percent change problem, just like we did in the first half of the video. And I'm going to do my best to write on the computer over here on the side. Let's see, what color do I want? Let's use red. I like red. There we go. We'll use red. So remember that equation to find percent, and I don't feel like I'm going to use shorthand. We're going to say percent change. We have to take the new minus the old over the old times 100. Okay? So what is my new in this? Well, since I'm going from 94 to 96, my new is actually going to be 1996. So my new is the 3,718. 3,718. Sorry about my bad writing now. And I'm going to subtract the old, which was in 1994, which is 2,215. And I'm going to divide by the old, which is 2,215. And when I finish this part out, I'm going to multiply it by 100. All right, so let's use our handy dandy calculator. 3,718 minus 2,215 gives me 1,503. And then we're going to divide that by my 2215. Multiply by 100, and I get that it's about 67.855 and a bunch more numbers. Blah, 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 blah. All right, but now let's look at what the problem states. It says round to the nearest hundredth as needed. Well, let's change the color. My hundredth spot is right here, is this 5. So this 5 is telling that 5 to go up. In doing so, it's going to be 67.886. All right, so let's find out if we're right. 67.86. And we're right. Okay, the next one is pretty much the same thing. I am not going to work this problem out with you, but look at it. It says just read the problem. But notice and see, it's asking for the percent increase from SEER from the base model to the high-end model. So your SEER is that light blue, and it's looking at the base model, which happens to be 10. And then the high-end model is approximately, I would go 16, that's about 17. So you know what the new is, it's going to be 17. You know what the old happens to be, which is 10. Well, calculate your percent change. And it's the same thing in D. Calculate the percent change in EER. Look at your EER from your base model. Look at your EER in your mid-range model and calculate your percent change. All right. This one I will take a little bit of time because there is a problem later on in this question that throws a lot of people off. So let's do the easy part. Let's answer these basic questions. Approximately how many successful bone marrow transplants were in 1998? Well, in 1998 we were here. This first little dot right here. So we need a calculator. Well, first thing is we need to find out, excuse me, we need to find out what numbers this is counting by. So let's count by 5. This would be 30. The next line would be 35, 40, 45, 50, 55, 60. Good. That means that each line is counting by 5. So this dot would be at 30, 35, 40. So your answer that you probably look at is going to be 40. All right, so let's plug it in. And it works. All right, then it says how many were in 2007. So we look at 2007, we go all the way up to the top. We notice that this is one tick below 180. And since this is counting by fives, we can basically say 180 minus 5, and we find out that this is 175. And if you don't like what I did right there, you can start at the 150. 155, 160, 165, 170, 175, 175. All right, now let's clear out some stuff here. Yoink. And let's look at this next problem. It says, by what percent did the number of successful bone marrow transplants increase from 5? Wow, let me start over. I'm stuttering. By about what percent did the number of successful bone marrow transplants increase in the 5-year period from 2002 to 2007? All right, so a couple of things that we need to take a look at is 2002 and finding out how much they made. So in 2000, I'm going to be lazy and just put 02. They made, let's look at it, we'll go here, comes across here. I would say, and that's just below the 120, they made 115 successful transplants. And then in 2007, they had 175. So in 2007, they had 175. All right, so what is the percent increase? Well, this is a percent change problem. It's the new minus the old, divide by the old, times 100, because this is a percent change problem. That C don't look very good. There we go. Percent change. Now it looks like a 3. But anyway, you get the idea. So we plug in what we know. We know that our new happens to be 175. We know that our old is 115. And so we put all those in the correct spot in our equation, and we work this out. 175 minus 115, divide by 115, multiply by 100, and you get 52.1739, blah, 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 blah. Now, look at what the problem states. It says round to the nearest whole number as needed. Well, my nearest whole number is right here, is the 2. So that 1 tells that 2 to stay the same, so my final answer should be about 52%. So let's find out if we're right. Good job. Okay, now let's look at this next problem. If the bone marrow transplant program increases at the same rate over the next 5 years, how many successful bone marrow transplants can the hospital expect to perform in 2012? All right, so I'm going to clear out some space over here, but I am going to write a number down so we don't forget it. I want to write down 52%, and then I'll explain why I'm writing that down. Because what's happened is, long story short, we need to use the answer from C to help us find D, the question D. All right, so let me clear out my space. All right, delete. All right, now think this through. Don't worry. Look, the biggest problem most people have is they see that word 5 years. Don't worry about that. This is a percent increase problem. You want to know how much you would do, how many transplants you're going to have if you have a 52% increase. So let's look at 2007. In 2007, you had 175. Well, let's change the color to purple. So in 2007, you had 175. But you want to know what happens when you have a 52% increase. So how do I do that? I'm going to take 175 and I'm going to multiply by whatever 52% of 175 is. This should ring a bell because this is what we did in the first half of the video. So we need to find the physical change here, this physical thing. So we're going to say 0.52 times 175 gives me 91. So if I increase consistently, that means by 2012, I am going to have 91 more successful transplants. So altogether, I'm going to have 175 plus my additional 91. When I do all that, I should get 266. So let's see if we're right. And we are. All right, so in this particular problem, the biggest ones whoops, let me go back. Sorry about that. The biggest ones that I'm concerned about are C. First off, find your percent change. And then in D, use that same percent change to find what the percent increase would be. All right, this one right here. Yeah, I do want to talk about that one too. Clear off my board. All right. Now, okay, this part's easy. Which category is the largest expenditure? Well, look at the graph. Which chunk is bigger? Hey, tuition. All right, so click it up. All right, I'm done. Which is the smallest? Well, the smallest chunk. Hey, lab fee, 7%. Click it. All right, I'm awesome. Now, this one is a little bit tougher. The students spent a total of $2,600, so the combined amount that went towards let's just read C first. This might be a little bit confusing. It says this: if a student spent a total of $2,600, how much of it went towards tools and lab fees combined? All right, so let me help you out on this one. The best way to solve this, probably the most quickest way of solving it, is setting up a proportion. Oh no, not again. Proportions, Mr. Lewis, I hate those. Suck it up, I don't care. All right, so you have a proportion. Remember, when you go to do a proportion, it is what you know, okay, versus what I want to know. Well, what do I know right now? The students spent $2,600, all right, on their everything. Well, since they're spending $2,600 on everything, what percentage is that? Pause, just think that through. This entire pie represents $2,600, but it also represents a percentage. So if I wanted to calculate that out, I could say, hey, 40%, 7%, 10%, 19%, and 24%, and I add all together, and I'm not even going to have to do that because it's 100%. What am I trying to tell you? That 100% of my money went to the college, and it was $2,600 altogether. I know that 100% is $2,600. That's what I know as a fact. Now, what do I want to know? I want to know how much went to tools and lab fees combined. Well, tools is 24%. My lab fees is 7%. So when I combine the tools and the lab fees, that's 24 plus 7%, and it gives me 31%. So what do I want to know? I want to know how much 31% is. I know that 100% is $2,600. And I want to know how much 31% is. So I've set that proportion. Now, the next thing I want you to remember is, in this particular problem, what's on top stays on top. So I put percentages on top, percentage stays on top. Money is on bottom, stays on bottom. Now, the other thing you should notice is that I didn't use decimals in this particular problem, and that's okay. I don't have to use decimals in this particular problem because I've set up a nice proportion and the math just works out that way. If you want to change 100% to the number 1 and you want to change 31% to 0.31, you can, but it's not necessary. All right, so now that we know that we're setting up a proportion, we cross multiply and divide. 100 times x gives me 100x. Is equal to 31 times 2,600, so 2,600 times 31, and I get 80,600. but I'm going to divide by 100 on both sides. And when I do, I get that X is $806. So what did I just find out? I know that $2,600 went to my entire college spending for the school, but only $806 of that total money went to my tools and to my lab fees. So let's find out if we're right. 806. And we're right. Okay. Next one. We're going to do the same thing again. We're going to set up a proportion with what I know versus what I want to know. But in this problem it says a student spent $400 on material. So what do I know? I know that material is 10%. And I know that it was $400. Okay? What do I want to know? How much is book and labs? Well, books and labs is 19%. And I want to know how much that is. So I set up a proportion. So I'll work this out. This is going to give me 10x is equal to 19 times 400. Gives me 7600. Sorry about my handwriting again. Divide by 10 on both sides. And I get that x is equal to 760. Woo, that was a bad 6 right there. So what did I just find out? I found out that $760 went to pay just for books and lab manuals. So let's see if we're right. And we're good. All right, so this one's a big problem, and I am going to go ahead and tell you this question is on your test. All right, and this question is on your test. Okay, so make sure you know how to do 3 and make sure you know how to do 4. All right, so the rest of it's pretty much self-explanatory, and I'm going to speed through this now because I know you're tired of me talking. You have a chart. Your job is to find which one of these graphs makes that chart. So look, region A is 12, so I come over here and I look at A, and notice how this A is above 10. That's approximately 12, so that's good. So let's take a look at this one. This A, well, that's about 12, so I'll go with that one. This A, that's about 12, so okay, I'm cool with that. Now let's look at B. B is at 11. Well, look at this B. It is below the number 10. Well, that can't be possible because according to our chart, B is 11. So we can rule out A. A is not our answer. Let's look at B. Well, according to this chart, its B is approximately 11. So, hey, this one's good so far. Let's look at this one. B is at 5. Well, B is 11 according to our chart, so we can rule out C. So our correct answer is B. All right, so basically all I did for this problem is look at each individual graph and rule it out based upon the information that I've provided for you in the top. All right, and it's the same thing for the next several problems, and I'm not going to waste my time talking about it. Look at the chart and compare it to the graph and see if it matches. All right, same thing. Now, oh my Lord, there's 2 graphs. Okay, look, you have 1900, you have 10.1 and 0.8. See which one of this matches. Well, this is about 10, this is about 10. Okay, this is, you get the idea. I'm not going to waste my time anymore. Figure out which one matches. Just understand that blue represents marriage and red represents divorce. Same thing, common sense. Find the chart that matches. Up, look again, same thing. Number 10, hey, it's the same thing. Look at 11. Hey, it's the same thing, but just with the pie graph. So that's pretty much about it. Actually, that is it for this section. So we've covered percent change, how to do percent increase, decrease, and how to read some graphs. And this video is done. I will see you in the next video. Bye-bye.